Welcome to helpyourmath.com. In this video, we're going to look at examples of solving logarithmic equations when checking your work is actually part of the problem. And I say it's part of the problem and not just like an optional step because if we look at a logarithmic equation, we have log base b of x is equal to y, we may recall that the argument, which is usually where the variable is found in logarithmic equations, the argument must be positive, so x must be greater than 0. And with some logarithmic equations, we might end up with values that would provide a negative argument, which is not a thing that is allowed. So we need to make sure that we're checking all possible solutions and checking to make sure they don't actually provide a negative argument. So in our first two examples, let's see, we need to combine into one logarithm because we have two logarithms, and that's not good. Since they have the same base, there's no base given, so that's assumed to be base 10. We can combine them using multiplication. This is same base multiplication. So we can write this as log base 10, and then we would multiply the arguments. 2 times 5d is 10d is equal to 3. Now what you can do if you want is you can put this in exponential form. That would be 10 cubed is equal to 10 times d. 10 cubed is 1000 equals 10d. Divide both sides by 10, and we end up with 100 is equal to d. Now we need to plug in and make sure that d really is the solution. So if I plug in d up here, that would be 5 times 100, which would be 500. So we would have log of 500 plus log of 2 equals 3. That's okay because we have a positive argument here and we have a positive argument here. So we're good to go, and it's confirmed that d in fact does equal 100. That's when we need to check is immediately at the beginning of the problem. That's where we would see some sort of issue. Let's see, we might see one here. So we have log base 2 of x plus 2 plus log base 2 of x equals 3. We want to get this to one logarithm. Since they're separated using addition, that means we want to multiply the arguments. So this will be log base 2 of x times plus x times 2, which will be x squared plus 2x. So we've multiplied. That means I need to distribute x to x and to 2. And this equals 3. Now that I have just one single log, now I can put this in exponential form. That would be 2 cubed equals x squared plus 2x. Since this is a quadratic equation, I do want to set it equal to 0. I could use completing the square, but I think this is going to be factorable. Usually these are. So I just want to see if it's factorable. I'll set it equal to 0. 2 cubed is 8, so I'm going to subtract 8 from both sides, and we get 0 equals x squared plus 2x minus 8. Target product is 8, target product is negative 8, target sum is 2. This is going to factor into x plus 4 times x minus 2. Now that we have two factors whose product is 0, one of the factors must be 0. If this is the one that equals 0, then x equals negative 4. If this is the one that equals 0, then we have x equals 2. We need to check both of these to see if they are in fact legitimate solutions. So we'll start with negative 4 since that was the first one I found. And when I go to plug it in, I get log base 2 of negative 4 plus 2 plus log base 2 of negative 4. I can stop right here. There's a negative argument right there. Not good. It gets thrown out. It was not actually a solution. Okay, done with that one. And you can see what would happen here. Once you go to combine the logarithms, the negative times the negative will turn that argument positive, but there's a block from the beginning because negative 4 was never going to be an allowable value for x. If we just check 2, we get log base 2 of 2 plus 2 plus log base 2 of 2 equals 3. This one looks good because here we have log base 2 of 4 plus log base 2 of 2. Yeah, I think this one's going to be solid. We'll just finish this. Log base 2 of 4, that's 2 because it's asking what power of 2 is 4. That's the second power. And log base 2 of 2 is 1, and 2 plus 1 does equal 3. So we have one solution to this, and it's x equals 2. That x equals negative 4 got thrown out. Two more examples here. This one's good to go. We're ready to put it straight into exponential form. That would be 3 to the 0. Equals a squared minus 2. 3 to the 0 is 1, so we get 1 equals a squared minus 2. From here, it's a quadratic. It's up to you in this case because there's no middle term. So maybe you want to add 2 to both sides. Normally with quadratics, we want to set it equal to 0, but since we don't have just an a term, we can do this and take the square root of both sides, and then we get plus or minus the square root of 3. To get the a squared, to undo that, we would take the square root. So I end up with the positive or negative square root of 3 is equal to a. If we want to, we can approximate. I don't think we're going to want to do that. I think we're just going to want to see if these are in fact both solutions. So then from here we would want to check. Let's start with the negative square root of 3. So is it okay that log base 3 and then we have negative root 3 squared minus 2 equals 0? Well, this ends up becoming positive 3, so that's okay. 3 minus 2 is positive 1. And we end up with log base 3 of 1 equals 0. That's totally fine. And then I notice if we plug in positive square root of 3, we will also end up with a 3 here. So both are legitimate solutions. So here we can say a is equal to negative square root of 3 or positive square root of 3. In the next example, and perhaps the final, yes, in the final example, again, we're good to go in terms of there's only one single logarithm, so we can put it right in exponential form. This would be written as 4 to the 1 equals 6w minus 24. And now this is a nice linear equation. So with linear equations, we want to move everything away from the variable. We'll start by adding 24 to both sides. This gives us 28 equals 6w. Now to get w by itself, we'll divide both sides by 6. 6 doesn't go evenly into 28, but they are both divisible by 2. That would be 14 over 3, which is equal to w. So you could either leave it as 14 over 3, or you could convert it into a mixed number. 3 goes into 14 4 whole times, with 2/3 left over. So either way is fine. We should check our work and make sure we don't end up with a negative argument. So let's check. I'm going to go back to the improper fraction. Ooh, I already put a box around it. I am sure that this is going to work, apparently. Okay, I'm going to check down here because there's more space. This is log base 4 of 6 times 14 over 3 minus 24. Does that equal 1? This would be 1, 2. This would be 28 minus 24. So we would have log base 4 of a positive argument, and we're good to go. And log base 4 of 4 does in fact equal 1. So that's a good thing I was sure, because that was the answer. Thank you for stopping by.